The supervolcano under Yellowstone has the potential to spew forth a super eruption. That's like an eruption from a volcano, but far more super, like change the climate big. Eruptions of hotspots within Yellowstone have happened more than once before. If something like this happened today, it would be catastrophic, said Shamloo. We want to understand what triggers these eruptions so we can set up warning systems. That's the big picture goal. The image above comes from EOS and was captured by Shamloo. This image depicts Christy Till as she points at an ash layer within the Lava Creek Tuff at the study site near Flag Ranch, Wyoming, just south of the Yellowstone boundary. Of note, Shamloo worked with Christy Till on this project. Till is a geologist and assistant professor in the School of Earth and Space Exploration at Arizona State. Supervolcano eruptions, likely incomplete list. Bruno Garbage caldera 11,830,000 years ago. Hias volcanic field 6,400,000 years ago. Hias volcanic field 6 million years ago. Hias volcanic field 4,500,000 years ago. Huckleberry Ridge 2,100,000 years ago. Henry's Fork caldera 1,300,000 years ago. Lava Creek Tuff 640,000 years ago. Some of the more notable eruptions can be found in the magma chart below. This chart comes from the Yellowstone Volcano Observatory. At Yellowstone's Lava Creek Tuff, Arizona State University's Hannah Shamloo collected samples of rhyolite ash. She spent weeks collecting samples, then analyzing their contents. Inside the rocky ash, she looked for crystals called phenocrysts. Above, feldspar phenocrysts from the Lava Creek Tuff. The outermost layers, which contain tiny bits of glass, are to the left. The phenocryst may be a fraction of a larger crystal that grew within the magma chamber, or may have adhered to a different crystal on the right, explaining why layers are roughly vertical rather than concentric. Red represents the path of an electron microprobe, which cut through layers to collect chemical compositions. Via EOS, images by Hannah Shamloo. The speed at which the crystals formed can be seen in the composition in which their molecules were arranged when analyzed. Magma surrounding the crystals immediately before the most recent Yellowstone eruption are represented by the now outermost rims of the crystals. It is in these outer rims that the time between a trigger event and an eruption can be found. The size of each unique arrangement of molecules in a crystal show the speed at which they formed. In the case of the crystals found in the stones found at Lava Creek Tuff, change occurred quickly, especially near their outer rim. Faster formation of this outer rim means a shorter time between the trigger for an eruption and a full eruption, aka in this case, a super eruption.